You're standing on the floor right now, or sitting in a chair, maybe lying in bed, and you're not falling through. That seems obvious. Normal, the floor is solid. Of course you're not falling through. That's just how things work. But why? No, seriously. Why doesn't your foot pass through the floor? Why doesn't the chair collapse into itself? Why is anything solid at all? You might say, well, the floor is made of atoms, and atoms are hard. They push back. But that's not an answer. That's just restating the question. What makes atoms hard? What's doing the pushing? Here's the truth. You are not touching the floor. You've never touched anything in your entire life. Your foot is not in contact with the floor. There's a gap, a tiny gap, but it's there. And in that gap, something is pushing. Something incredibly powerful. So powerful that it holds up your entire body without you even noticing. Dangia. Let me tell you what's really happening. And I'm warning you, once you see it, you'll never feel the ground beneath your feet the same way again. Start with atoms. Everything is made of atoms. You, the floor, the air, everything. An atom has a nucleus in the center, protons and neutrons packed together, and around that nucleus, far away, are electrons, clouds of electrons, wave functions, probability distributions. We've been through this before. Now, the nucleus is tiny, incredibly tiny. If you scaled an atom up to the size of a football stadium, the nucleus would be a grain of sand in the center. The electrons would be buzzing around the outer walls, and in between, nothing, empty space, or close to nothing. Quantum fields, vacuum fluctuations, but no solid stuff. So an atom is almost entirely empty space. And you're made of atoms. The floor is made of atoms. Both of you mostly empty. So why doesn't your mostly empty foot pass through the mostly empty floor? Here's what people usually say. They say the atoms touch. The atoms in your foot bump into the atoms in the floor, and they can't overlap, so you stay on top. Simple contact, wrong. Atoms don't touch. Ever. The electrons in your foot and the electrons in the floor never make contact. They get close, very close. But they don't touch. Why not? Because electrons are negatively charged. And like charges repel, the electrons in your foot push away from the electrons in the floor. The closer they get, the harder they push. This is electromagnetic repulsion, one of the fundamental forces of nature. And Blanton, but wait, if they're not touching, what's stopping you from falling through? If there's a gap, why doesn't your foot just slip through that gap? Blangy, because the repulsion gets stronger as they get closer. It's not a fixed force. It's not like a wall. It's a force that increases with proximity. The closer the electrons get, the harder they push each other away. And that force, that electromagnetic repulsion, is enormous. Let me put a number on it. The electromagnetic force between two electrons is about to the Caesarean power times stronger than the gravitational force between them. That's E followed by Caesar R zeros. The electromagnetic force is so monstrously stronger than gravity that gravity might as well not exist when you're talking about electrons. So when you stand on the floor, what's really happening is this. Gravity is pulling you down. Your weight, your mass being pulled toward the center of the earth. That's real. That's always happening. But the electrons in your shoes are getting pushed up by the electrons in the floor with a force so strong that it completely overwhelms gravity. The floor pushes back, not because it's solid, because the electromagnetic force is holding you up. You're levitating right now, hovering on a cushion of electromagnetic repulsion. You're floating just above the surface, held up by forces between particles that never actually touch. Now you might ask, okay, but why does the floor feel solid? If I'm hovering, why does it feel like I'm standing on something hard? because the electromagnetic force is extremely stiff. It resists compression. When you push down on the floor, the electrons in the floor push back harder. The harder you push, the harder they push back. It feels like a solid barrier because the force ramps up so quickly that you can't compress it. Think of it like a spring, a very, very stiff spring. When you press down on a spring, it pushes back. The more you compress it, the harder it resists. The electromagnetic force is like that, except billions of times stiffer. You can't compress it, you can't push through it, so it feels solid, but it's not solid. It's a force field, an electromagnetic force field holding you up. Now, let's go deeper. Why do electrons repel each other in the first place? What's the mechanism? This is where it gets really strange.